where we'll be talking more about mobile games and how to make them and all the workflows and rendering improvements we've shipped with 5.2 and 5.3. My name is Axel. I'm French, but I've been in Japan for more than 10 years now. I've shipped multiple AAA titles using Unreal Engine, and then I joined Epic Games about 5 years ago, where I'm helping licensees optimize, debug, and eventually ship the titles, then with UE4 and now with UE5. I have been working very closely with a mobile team for years now, where I take part of the runtime and pipeline development and new feature set for Apple platforms mainly, so Mac, iOS, and tvOS. But first, before we get into business, this is my first time in India, and it turns out it's an amazing timing because last week was my friend's wedding in Raipur. So I've always been a huge fan of Indian food, but like this is next level compared to what we can get in Japan. So I'm like extremely grateful and fortunate to be able to experience this. We went to Raipur, then the wedding was in Raipur, then we went to Kanha to do safari, then Jaipur, which is like one of the most beautiful cities I've seen in my life. And then Delhi and Agra, it was so cool. Really love it. It turns out I'm also a huge fan of director S.S. Rajamouli, and I do think RRR is one of the best movies I've seen in recent years with Top Gun Maverick. I like it so much that at my friend's wedding, we danced Nattu Nattu, actually. And I have to say, we were not terrible. We were not good, but we got the steps pretty much. And yeah, and you know, safari, we got to see tigers playing together. How cool is this? Like wild tigers in Kanha, this was so cool. Okay, now let's talk business. Disclaimer, spoiler alert, this is going to be a technical talk, so enjoy. First, let's look at the few UE mobile titles that have been shipped with Unreal Engine in the recent years. This is the Oregon Trail made by Gameloft in Brisbane, Australia. This is another one. This is a Marvel Future Revolution by Netmarble. You can see that the quality of the graphics is actually very good, and which would typically be what you would see on home consoles now. And there is another game by Netmarble coming from a Japanese IP called Ni no Kuni. This is also a great testament of how you can ship non-photorealistic games using Unreal Engine on all platforms, including mobile. This is another one, Tower Fantasy, very successful title. And obviously, we have our own thing in Epic called Fortnite, which runs on Android very smoothly. This will be one of the points I will be talking about more in depth into this talk, but this is, in my opinion, something that is really overlooked about Unreal Engine. It's not about being able to ship games on all the platforms that exist. It's being able to do so cross-platform with just one project. I mean, for Fortnite, for example, in Epic, we do not have a different project for Android and for Nintendo Switch and for PS5. This is all the same project and the same materials that then get adapted on the, when you try and build for every specific platform. But you can really leverage Unreal Engine to do real cross-platform titles. Here is the focus that the mobile team has been working on in 2022 and 2023. First of all, as Arvin said, improving developer workflows, things such as these of development and iteration time and PIE performance and preview and scalability for cross-platform, as I was saying, has been a huge focus of us. Also, improving performance and compatibility. For mobile, I would say that we have been working really hard with Vulkan drivers mainly, and to reduce memory usage also. But while doing this for today, we've also been preparing for the future with the now very fancy Android phones that you can fold and stuff like this. It's really cool. And things like hardware ray tracing that I will talk in depth later in this talk. Here is today's agenda. First, I will talk about what I know best, which is the iOS side of the engine that I work on. I will do a full update of all the workflows and improvements in iOS for Unreal Engine 5.2 and 5.3. Then I will need you to be very nice to me because I will be talking about Android. And to be fair, I do understand a bit Android, but I still have so much to learn. And then we'll be talking about all the rendering side of mobile and all the improvements we've been working on. And we'll finish off nicely with a future of mobile rendering. So first, iOS. I consider Unreal Engine 5.2 and 5.3 as the biggest releases for Apple platforms in years for Unreal Engine. We have revamped the way we are using and interfacing with Xcode. Basically, we are now way closer to the Apple way of managing code and project instead of trying to hack through it. We now have one Xcode workspace by platform, which means that you will have 3 workspaces when generating solutions, one for iOS, one for tvOS, and one for Mac. Previously, when changing from editor to client, you had to change targets and schemes, making it not really user-friendly. It's now way easier to work on editor and, let's say, iOS client at the same time. You'll feel at home in just a few minutes. This is one of the biggest changes we've made in recent years to the Apple platforms. This is what we call internally modern Xcode, in opposition to ancient Xcode. That was the way we were doing it until now. We are changing the whole way we are handling signing process for iOS apps. I promise you, now, you won't spend 2 days banging your head on the walls. You will just spend 1. You just have to make sure that you're logged in to your dev account in Xcode, turn on automatic signing, and choose a development team, which can be set on the Apple Dev Portal website. These settings will be used as ground truth for signing by Unreal Engine. Strictly speaking, if it works in Xcode, it will work in Unreal Engine. You won't have to use the project settings anymore with the iOS section and the provisioning and everything, or have fun and troubleshooting with the ifn packager for Windows. So for now, it still have a few rough edges, but it's really usable. And legacy Xcode and modern Xcode still live side by side. Modern Xcode is the default it's activated by default in Unreal Engine 5.3, and the old way will be sunset in a future release of Unreal Engine. We have added for 5.3 what is called the Stage Manager for iPad, which is how you can have multitasking on the same screen at the same time. This is really good for resizing, dynamic resizing, having multiple apps at the same time. It's working really well on iPadOS, and this support was necessary to get a native iOS apps that are now working on Mac. It's only on Apple Silicon, because this is obviously a limitation we have, set by Apple, basically. It's great to have this working, and you can imagine now that you can bring your iOS game to new audiences, because your iOS games will run on Mac. One of the benefits is now, as a developer, you can easily test and iterate. But this is definitely a user-focused feature, though, so developers might find use for it, but this is definitely for end user. What is developer-focused, on the other hand, is iOS Simulator, that now works. It's still being experimental in 5.3. It allows you to iterate faster than on device, because you're not limited to the USB 2 bus for lightning cables on your iPhone, for example. So if you want to do quick tests, this is really good. It's useful for automated tests, for debugging, because it can interface quite well with Xcode. And you can just enable it in the project settings section of Unreal Engine. This said, it has limitations. This is not our fault, basically. This is the way Apple is handling things. But the graphic feature set is very similar to what we have on SoCs, such as the A8 and A9, which are, 5-6 years ago things. It's like ancient. You will also need to have separate build steps for third-party libraries and several other limitations, which make things a bit harder for now, but looking at the way that iOS apps run natively on Apple Silicon Macs, I'm pretty sure Apple will update iOS Simulator and the future release of Xcode, making this feature really, really good when you try and debug your game. One thing that I'm really proud to have shipped this year for iOS is the new memory allocator. Memory allocator is not new, but the way iOS support for it is new. Now we have extended virtual addressing running for iOS. This is really cool because you just have to activate the entitlements on Apple Dev Portal, and there will be a runtime check looking at your entitlements within your app. And if you have the entitlement activated, then you will automatically go to malloc bin 2, which allows virtual addressing for memory. So which, as when you make your game, allows you to have way bigger assets and without really having to worry about memory so much anymore. I would also encourage you to use the increased memory limit entitlement that you have available, because if you have more memory, there's no reason to use it. I will say though that I would really encourage you to thoroughly test every single scene for every single device that you're shipping on, because it's really non-obvious, but things that may look like they have similar memories actually don't. For example, an iPhone 14 Pro and an iPhone 40 Pro Max, you would say, oh, same memory. It turns out it's slightly different, the memory profile. So make sure to test everything before shipping your game. One of the things I've also worked on, I'm very happy about, is what we call prepare for debugging. It is a convenient way to get a packaged iOS app into the Xcode debugger. Basically what it does is, let's say you have your nightly build Jenkins server, whatever, being on the cloud or in a server room of your company. And you have your incremental build with a beefy Mac that is on the server room. And you can just, without having to rebuild or recook any assets or any C++, or actually you will have to build C++, but without the need of recooking any asset for cook content, you can just use a previously built Python package as a donor IPA and inject the cook content to a locally built, Xcode built binary, which might seem complicated, but it's really not. We have a documentation about it that if you want to use the feature, I would encourage you to read it. You have two ways of using this. The first, and in my opinion, the best one, because the whole point is not having to build the editor and do the cooking again. So you just have to run a UAT comment from the Turnkey initiative called Wrangle Content for Debugging. So it's called this because I was in my cowboy face when building this comment. So Wrangle, yep. You just specify the your project file, and it will just automatically go and look for the donor IP in the binary iOS or tvOS folder, and use this as injected in the payload that you are building on in Xcode in your local Mac. So there is a complete documentation about it, so please check it out. But this said, prepare for debugging is a two phases feature, and this was the Mac part. Now let's talk about the Windows part. So it's a reality that even if you ship a game on iOS, most of the development will be made on Windows for multiple reasons. The one that is, there are many valid reasons to do so, but one I often see is like if you make a cross-platform game, you will probably have, let's say you make a console game, SDK will most likely not be available on Mac. So you have to use, if you use Visual Studio and SDK integration inside of it, you will have to be PC-based. So what do you want to do if you want to ship a game on iOS 2? There are currently 3 patterns. The option A is really not ideal, but it turns out that if it's a blueprint-only project, because blueprints in the end is content and not code, you don't really have to rebuild C++, so you don't need a Mac. And we have Python packager tool that just that is able to resign a package and just deploy it to your iPhone from a Windows machine. This is actually super hacky and super great, and I love it. But this is like cool for prototyping, for hobbyists, for students, not really for full-fledged game development, in my opinion. Which brings us to option B. Option B, which is today still, I think, one of the most common one, is you will have everybody working on Windows, then you will have 1 or 2 Macs available in your company that will work on the iOS version of a game and see if everything runs smoothly. But let's say that you're facing and you have a bug on iOS. Then this one person with access to the single only Mac will become de facto a bottleneck for your production, where you will have to stop and wait for him to fix the bug and not be able to iterate correctly. So this is not ideal. So there is option C, we've shipped with Unreal Engine like a couple of years ago, using leveraging what we call remote build. So you're basically from Windows, and you have, let's say, a Mac Pro or a powerful Mac available somewhere in the company, but not on your desk. And you just SSH through it and just build everything you need to, and you bring back all of the cooked and built content back to your Windows, and then you just deploy it to your iPhone using the iPhone packager. This is actually quite usable and quite well integrated. But there is a huge problem with this what do you do when you want to debug on iOS? Because you will need Xcode, right? So if you don't have a Mac available, you can't. And most of the bugs can probably be fixed in PIE or other client version of a game, but some bugs will be iOS only. So you will need to have physical access to a Mac at some point. So there has to be a better way. And this better way, we have shipped it with Unreal Engine 5.3 as experimental. This is basically a mix of option B and option C. You work on Windows, and you remote build to, let's say, a beefier Mac, and then you can have a really super old, super cheap, let's say a MacBook Air or something, Mac somewhere available in your company, and you don't build things on this MacBook Air. You just get all the results and the pre-built and the pre-compiled assets from the Mac Pro back to this Mac Mini, let's say, and you can just deploy it and debug and just have it working in a few minutes instead of having to rebuild everything locally. So this is a real big change for iteration on macOS when working on iOS. So it's shipped as experimental for 5.3. It still has a few rough edges that we are working on, but this is definitely usable. And how to set it? It's you go to your project settings, and you will find a new section called secondary remote build options. You just fill it in, just like you used to for the remote build. And what it will do, you can see it on the left, is have everything packaged to the Mac Pro, brought back to your Windows, but will it then send the build products to a Mac Mini, where you can now debug in Xcode. And let's see a demo of this. So I'm on my Windows. This is a C++ project template. I'm going to my Visual Studio, and I will just be adding some log for testing. OK, I save. There you go. It's within the move function of my character movement. Then I go check my project settings and see that remote build is correctly set. It's at the bottom. There you go. Remote build is correctly set. This is basically my Mac Pro in my Jenkins room or something. And then you have this new secondary remote Mac, which will be your Mac Mini or your, cheap old Mac, which is my Mac Mini. That is right there. And then you just click Platform and Build for iOS. So this is building on the Mac Pro. And boom, there you go. You have your IPA that has been retrieved on your Windows. what you do now is use this new option called Prepare for Debugging within iOS. And what it will do is get all of the compile content as well as the IPA sent to your Mac Mini. It takes a few seconds. You can see you have an Xcode workspace here. You can open it up. My iPhone is attached to my Mac using USB. And instead of running it, you use the option called Run Without Building to be able to use the previously built C++ files. And you see that the updated code with the log is in the move function, just like on Windows. You get logged. It's running. OK, now let me add a breakpoint. Let's see if it breaks. OK, there you go. So it breaks. I have access to all of my local variables. I have access to LLDB. I can thoroughly inspect this problem and look into it. So this would be like, what, a 2-day things to have it set up until 5.2, and now in 5.3 we are talking about minutes. This is a huge improvement, and I would like some feedback about it because it's still experimental, but it's working great, and we are using it within Epic. There you go. Now let's switch to Android. But before this, I have a very, very special announcement to make. Here's the very first Unreal Engine 6 pic. You can see the hair and fur is really improved. Now, this is just a joke. This is me taking photo of a tiger at Safari. In Ghana, it was so cool. OK. And then Android. So we have made a couple of updates in 5.3. SDK updates first. Now, Android Studio will be Flamingo Giraffe, and the new base SDK will be Android 33. There are reasons for this that I will go about later. There is also, I would say that the GDK 17 update solves issues with the Android Game Developer Extension, IGDE, which if you're not using, who is using IGDE already? OK, come on. Really? This is one of the best things for developing for Android that has ever come to light for C++. Please use it. I will talk about this on the next slide. There is no reason not to use it. It's amazing. But yeah, I will talk about it. So you should do the update if you use AGDE. And something that was kind of a surprise for us that we had to support is, so basically for API level 30 and up, 33 for new apps, now you do not have direct access to storage on device, so namely the SD card folder. This change is known as scoped storage, and it's now, when you want to ship your game on Google Play, this is now a requirement. But this said, these features still have some problems on some Android 11 devices, and later, especially when using ADB push. This is related to the scope storage, but this said, it's great. My voice is always giving up on me at the worst time. Sorry about this. So this said, this is only problematic for developers, not for final users. So this might be a pain for you, but not for your clients. So, you know. Give me 1 sec, please. To use it, you just have to enable the plugin within the project settings, and it will run in the context of your Android app. This is not enabled in shipping builds in configuration for obvious reason by default. If you want to try and use it in shipping builds because let's say a bug is only in shipping, do this at your own risk, and please make sure that you know what you're doing. And device compatibility has been greatly improved with Android 5.3. IFS is great to debug and iterate on device. So it generates a stub, which is a fake project build that we're using to iterate. And and standalone FA server signed with the same signing key as your shipping app, making things easier when you develop. And it can be installed over your shipping APK using ADB again with the install R command. You can read and write internal files from your shipping app that are not accessible over ADB. And you can also reinstall your actual real shipping app on top of a stub, which will maintain all the files, which makes it great to be able to reproduce and debug things. So, some miscellaneous updates for Android. Android, you now have basic support for all the folding phones within Unreal Engine 5.3. So the Samsung Fold and Flip and things like the Pixel Fold. More features are coming to support it in 5.4. You also have Samsung Split Screen, which is the Samsung equivalent of the Stage Manager for iPad. So you have like multiple apps at the same time on screen. It's also now supported, same with other vendors. You also have Aptics feedback API that is fully supported in 5.2 for controllers. So let's say you're making a fast-paced online game, a shooter game or something, and you have controller support, I would really encourage you to have it implemented. This is really fun and working really well. And along with some changes and improvements to the platform web browser for Android. So yeah, about IGDE. IGDE is a tool that we had some input on, but it's actually not created by us, but by Google. This is an extension for Visual Studio that allows you to really improve your debugging experience when making Android games using Unreal Engine. So it's a C++ focused feature, so obviously it will not work for Java code, but if you're making an Unreal Engine game, there's huge chance you're using C++ anyways. It's the official Google equivalent of Prepare for Debug for iOS that I've just talked about, and it allows you to mix pre-built content and package with locally built C++. So if you don't want to cook all your content every time to iterate on it and just debug, you can just use pre-built stuff, inject new C++ code, and there you go. It's really cool. And again, if you're not using it, please do. There's no reason not to. So this one is kind of random, but it's, yeah, from experience. You would think that all USB Type-C are USB 3, right? They're not. Actually, the bandwidth and the bus is very, very different. Up to 5x the speed if you're using the good cables. There is a way to check this. It's a tool called USB View made by Microsoft that allows you to check that it actually has a USB 3 performance. So this sounds silly, but when making games with big content for Android, we are talking about tens of minutes, if not hours, every day of time. That is just with just one single cable change. So check your cables. And then rendering. But again, Tiger first. Always Tiger first. Big cats. Yay. I'm so like, this is totally unrelated, but India is doing like such an amazing job at protecting wild tigers. I think like this is an amazing blueprint for the rest of the world to follow. Like amazing job, really. So let's talk about the differences before my throat really dies about desktop and mobile rendering. So for desktop renderer, mainly for home consoles and PC, it's called SM5 and SM6 that you may have seen in the engine. But the one for mobile renderer is, we usually call it ES31. This is used for Android, iOS, Nintendo Switch, but also can be used for low-end PC. This is what I was talking about first when talking about Fortnite. They don't render the same, but you use the same materials and lighting models, which is what's really important. Is like you can share assets for your whole project, and then Unreal Engine will just optimize it for all the platforms you're shipping on. This said, mobile renderer is optimized for mobile GPUs, and because a $300 Android phone is not a $5,000 computer, obviously there is some limitations to the GPU. For example, you can only have one single movable directional light, and also limitation related to movable point and spotlights, limited access to the G buffer, as well as simplified post-processing, no support for hair grooms, including tigers, no nanite and lumen at the moment, but things are going to change, and I will talk about it later. There is no point light shadows, and some advanced lighting models are simply not supported. There's also there's support for sky atmosphere, but it's to be honest, quite limited. This said, it's actually possible to run the desktop renderer on mobile. I would say that in most cases, you should not, but depending, if you want to have like killing ray tracing on super high-end Android, this is one way you could do it. And on mobile, we have two renderers, the forward and the deferred. They are quite different and will bring different results to your games. One sec. Okay. Mobile deferred rendering is designed to take care of what we call tile-based GPUs, which is the dominant GPU architecture now in mobile devices. And it will leverage it to render more efficiently the mobile renderer feature set. This still lives side by side with the forward mode. So then let's talk about them briefly. So mobile forward mode is super simple. When each object's triangles are rendered, lighting and shading is directly calculated and written out to the scene color output. And that's pretty much it. There is a huge advantage with it, is that yeah, thank you. No, just thank you. Yeah, appreciate. Thank you. Yeah, it's okay. This is why you don't eat super spicy biryani before talks, right? Lesson is learned. I won't do it next year. So, MSAA is by design, it's supported and is great for many devices, for example, in VR. But it has many disadvantages, like lighting cost depends on object geometry, local lights are very expensive, and overdrawn pixels have a lighting calculated multiple times, which is not optimal for performance. On the other hand, the new mobile deferred mode we've introduced with 5.1 and it's now production ready, when each object is rendered, base color, normal, roughness, metallic, are written into a tile memory G buffer in your GPU. And lighting and shading will be performed in a subsequent pass, reading straight from this tiled memory G buffer and writing it to the scene color output. I have to stress that the mobile deferred mode is not the desktop deferred renderer. It's not the same tool set, it's not the same feature set, it should not be mistaken for it. It has a lot of advantages, like lighting cost is independent of geometry because it's not calculated here. Local lights can be efficiently rendered, and a few extra rendering capabilities like deferred decals are possible with deferred and not with forward. Also, but on the other hand, MSAA, so MS anti-aliasing is not supported. So, the big question that you all want to know is like, which one should you use for your game? So, as a general rule of thumb, I would say that give deferred a try, basically. I would say as exceptions, I can find of 3 big exceptions. So if you use a lot of pre-computed lighting and shadowing, you will still have better performance with forward. And also, if MSAA is extremely important to you, let's say you're making a VR application, then you should probably still go for forward. But deferred is great. Games and applications using it's best for games and applications using dynamic lighting and shadowing. games using many local point lights or spotlights, and games making use of decals. Still, while tile-based GPUs are the norm now, it's not the case for every single Android phone yet, and other mobile platforms that still have big market shares, like the Nintendo Switch, are not tile-based. So for them, forward probably is a better idea. Okay, a huge change in the editor is a preview platform that is now working better than ever. It's the ability to use, to be able to preview on Windows in your editor how different platforms will look like. Things like you can have an accurate preview of, let's say, scalability settings that are set in your ini files, such as the Android scalability, and then everything LOD related, and all the rendering features enabled differently on different mobile platforms. Let's say Vulkan and OpenGL and Metal do not really have the same feature set, so you can preview them directly on Windows or in your editor. This is really good. Now, let's talk a bit about rendering updates. So how many of you have been using PSO caching? Yay, thank you, bro. So this is great. It allows you to pre-build shaders for them to be available when you have to use them. I will give you an example. You're making a fast-paced online shooter, and one of the players uses a new weapon with a different type of shader coming out of it when he's shooting the bullet. If you are compiling the shader at runtime, you will get a huge hitch because it will try and run it on main thread. So your player will have a huge hitch, will have a bad experience, and this is bad for you and for your game. So there has to be a better way, and this is PSO caching. This allows you to pre-build and pre-compile every shader before having to use them. This is great, but it has several problems. It had several problems, which is quite complicated to set up. It also requires you to recode PSO, so you need to pre-play every scene in order to know what shaders have to be built. So it's easy to miss PSOs that you need, or gather PSOs that actually you don't need. And every time you make a change, it has to be rebuilt at startup, so boot time for a game can be really bigger and longer, which is not ideal. So we've updated PSO caching. We now do it at runtime. So we are using threads in background to compile all the shaders before they are rendered. It will not run on the main thread, so there will not be any hitch. And we guarantee that every shader will be available. Every shader will be, when you use it, it will already be built. It's already running for OpenGL on Android. This is actually live in Fortnite. For Vulkan drivers, for Fortnite, we are shipping it this week, I think, if I'm correct. iOS, though, is still in development for Metal, but we hope to ship it for 5.4. There has been a lot of changes in 5.2 and performance in 5.3 for runtime virtual texturing. Basically, what it does, it creates a textual data on demand using the GPU at the runtime and works similarly to traditional texture mapping. Its implementation for mobile is now production ready, with big quality and performance improvements in 5.3. So if you're making an open world game with a lot of landscapes, this is a huge win on performance and fidelity. For example, on Galaxy S10, this only takes less than 2 milliseconds on GPU, so I think this is a great trade-off.
Some miscellaneous improvement. So we have some new ARM texture compressor with 5.2. It's better for compression quality. There is a higher quality normal map compression, and it supports AGR texture formats, which is great. In 5.3, the number of CSM shadow cascades is no longer baked into shaders. It allows to maintain performance for low-end mobile devices mostly. It's really good. Now, let's talk a bit about the future. So, I don't know how many of you know, but actually Nanite and Lumen, they do run Apple Silicon already. This has been shipped with Unreal Engine 5.2, Unreal Engine 5.3, sorry. This is for M2 and ops. So I have not tried because I was taking pictures of tigers, but I'm sure that it also runs on M3. There's no reason to. So it's using the desktop renderer. And I would say, so you have a Matrix demo running on Mac now with Nanite and Lumen. This is big. And while performance is not 60 frames a second, obviously, it's not as bad as you would think. So you should give it a try. And on the mobile side of things, the amazing thing about this is that now Apple is sharing a lot of its pipeline for SoCs from Mac to iOS. And there's actually an iPad using the M2 chip. So we hope to make progress into shipping Nanite and Lumen on high-end iOS devices that will be able to trickle down to other platforms later. On Android, so Lumen works on Android today. It's amazing. So it's using the desktop renderer version of it, so not the one I talked about, but the other one that you should not be using instead of except for use cases like this. But it runs. And it's crazy. We get actually very good performance. I have seen 60 frames a second using Lumen on Android. Obviously high-end, but still, it's magnificent. So it's supported on the following GPU architecture, on the following GPU on Android Adreno 740, which is the one in the latest Galaxy, as well as the Exynos variant for the one of last year. And also the Immortalis G715, which is equipped with the latest pixels. I would really recommend you to watch Qualcomm's session that they've done last month at Unreal Fest in New Orleans, called The Bright Future of Mobile Ray Tracing and Unreal Engine, where they go in depth into how we've implemented it. It's amazing. Now, Lumen done, let's talk about Nanite. So, finally, modern, latest Android GPUs have support for 64-bit atomic extension, which is a requirement, a hardware requirement to run Nanite. So, this said, we do not think it performs well at the moment. So it's not really practical for games today. But again, such as exactly the same as Apple, where they are really pushing this kind of tech into their chip, and us trying to really push forward with them on this. Like, the future is clear. Nanite and Lumen will be the norm on iOS and Android. I will give a few, just one mention to UEFN. UEFN, when you make game on Windows using the editor, you can deploy on Android from Fortnite, and even streaming platforms to iOS, such as GeForce Now. I don't know if it's available in India, but if you want to reach global market, you should definitely think about it. And with this said, thank you so much. Now this is not a tiger, this is my cat. It's almost the same, just less big. My voice is really dying, so I would really appreciate if the questions were very short. But in case you have a long one, please send me an email. I would love to answer. And if I can't, I will forward it to the person in Epic who can. Thank you. What feature are you talking about?
Game design and game development in Unreal, something like that. Could you explain with a simple example?
Yes, so this talk was really about, it was super technical about all the advancements we've made for the mobile platform only. This said, how you make games. This is, you make games exactly the same way as any other platform. So we have hundreds of talks and tutorials available on YouTube and documentation in order to know how to use blueprints and C++ to make games with Unreal. So I would encourage you to check them out. Okay, thank you. And I will be on the show floor and the booth, so if you want to talk, please show me the games. I basically have no knowledge about all the games that are currently being made in India. I would love to see them. Let's talk about it. Thank you.